formulation. Drug formulations are mixture of the active pharmaceutical ingredient and selected inactive ingredients. Typically speaking, solutions formulations that are used for injectable drug types have less inactive ingredients, such as gas, co-solvents, buffering agents, and pH enhancers. Like some of the semi-solid formulations used for topical administration, they are also much easier to formulate. Air, oil, surfactants, emulsifiers, stabilizers, chelators, preservatives, and pH adjusting agent can be the inactive ingredients used in the semi-solid formulations. Due to the interactions between the various ingredients, this type of formulation appear to be complex and often involve significant research efforts during the formulation process. What are rheological properties? Rheological properties are extremely useful in characterizing particle liquid structures and in deciding how particle-particle interactions affect the slurry stability. All Newtonian fluids follow the same scientific laws. On the other hand, there are also fluids that do not follow the Newtonian flow laws. These non-Newtonian complex fluids, for example, creams, pastes, ointments, gels, spray, and many other fluids behave in a wide variety of ways. Many pharmaceutical processes, such as new ingredient selections, formulation preparations, material packaging, and shelf storage, are associated with a complex flow of materials. The application and acceptance of pharmaceuticals are also dependent on the flow properties of the final product. Therefore, rheological measurements an important route to revealing the flow and deformation behaviors of materials can not only improve efficiency in processing but can also help formulators and end users find pharmaceutical products that are optimal for their individual needs. Generally, rheological measurements on pharmaceutical materials are performed for the following reasons. First, to understand the fundamental nature of a system. Second, for quality control of raw materials, final products, and manufacturing processes such as mixing, pumping, packaging, and filling. Last but not least, to study the effect of different parameters such as formulation, storage time, and temperature on the quality and acceptance of a final product. Product conceptualization. First, we must understand that the substance being conceptualized has two primary functions, sanitizing and moisturizing, which two main ingredients will have to perform. The main ingredients for the product sanitizing feature will be an aqueous alcohol solution with a concentration of between 62% until 95% by volume. Moisturizers are complex mixtures of chemical agents including occlusive chemicals, humectants, and emollients, specifically formulated to make the epidermis smoother and more pliable and to increase its water content by reducing the evaporation effect. The fact that some of the compounds present in the formulations are hydrophilic and others are hydrophobic requires an emulsion as the proper vehicle of delivery. Moisturizing capabilities. One of the two key functions of developing product is its moisturizing capability. Moisturizers are complex mixture of chemical compounds designed to make the epidermis moisture and more pliable. Moisturizers may be categorized as emollients, humectants, and occlusive according to their physical properties and their mechanism of actions. Emollients. Emollients are mainly lipids and oils that are hydrate and enhance softness, durability, and smoothness in the skin. Intracellular lipids containing multilamellar structures in the outermost epidermis layer have a significant role to play in skin architecture. Humectants. Humectants are basically hygroscopic compounds that pull water from the dermis into the epidermis and absorb environmental moistures. However, humectants agents are double-edged weapons because they increase the loss of transepidermal water by enhancing the absorption of water from the dermis into the dermis where transpiration can easily be lost to the atmosphere. Because of this, they are often paired with occlusive agents. Glycerin, alpha-hydroxyl acid, propylene glycol, hyaluronic acid, urea, panthenol, and gelatin are some examples of humectant agents. Occlusive agents. Occlusive agents are substances usually oils, which by forming hydrophilic barrier over the skin physically block the loss of transepidermal water. Some examples of the occlusive agents are listed in the following table. Pharmaceutical emulsion. An emulsion of many immersible liquid is thermodynamically unstable dispersion. The most popular form of emulsion is those with two phases. One consists of a polar compound and the other one of a non-polar compound. The interferential tension present in the interface between the phases of oil and water must be resolved to form a stable oil in water emulsion. An emulsifying agent must be added to provide the emulsion with long-term stability, such as surfactants, which reduce interferential tension by absorbing into the device interface. In 1949, Griffin proposed the HLB scale for determining which surfactant to use depending on the type of emulsion that we want, and it has a big impact on the stability of that emulsion. Once formed, the emulsion stability depends upon the following mechanisms such as sedimentation, flocking, coalescence, and oswald ripening. Pharmaceutical suspension. Formulation step of an elegant suspension to make it as a stable system. 3 steps that can be taken to ensure formulation of an elegant pharmaceutical suspension. Firstly, control particle size by grinding down the ingredients to a fine powder using mortar and pestle on a small scale. Next, use thickening agent to increase viscosity of the vehicle by using suspending agents or viscosity increasing agents. Finally, use of a wetting agent or surfactants. Pharmaceutical colloids. Colloidal stability we need to prevent particles from sticking when they collide to maintain stability through Brownian motion. This can be accomplished by increasing the particle-related charges such as the zeta potential. Hand sanitizer in colloid dosage form should have long-term stability to control the flocculation. Van der Waals attractive forces and electrostatic repulsive forces are the main interacting forces in affecting colloidal system. Attractive forces tend to destabilize colloids, whereas repulsive forces generally impart stability. Electrical double layer. Formation of double layer is very important for stability of colloid. Double layer is sensitive to electrolytes and temperature. Stability of colloid may be manipulated by adding electrolytes or changing temperature. Zeta potential. Particles with zeta potential more positive than 30 mV or more negative than 30 mV are form a stable dispersion. Small changes in the pH or concentration of ionic strength can lead to dramatic changes in zeta potential. Colloidal stability and the LVO story. An energy barrier resulting from combination of the attractive and repulsive forces prevents particles approaching each other closely. Suggests that electrical double layers repulsion will stabilize the colloidal dispersion when electrolyte concentration phases is less than a certain value. Pharmaceutical solutions. Formulation problems. Formulation problems rise because of stability, sterility, organoleptic qualities, viscosity, tonicity, and specific gravity. Hence, the formulation should be considered by proper choices of drug solubilizing parameter and solvents, proper choice of stabilizers, and all the required adjuvants. Next, raw material used in manufacturing liquid should be properly checked for their specifications such as identity, purity, uniformity, and freedom from excessive microbial contamination. Pharmaceutical gel. Gels formulations are usually transparent or translucent, water-based solvents with excellent propagation properties and pleasing aesthetic properties. Gels derive their strength and rheological properties from polymers, which can sweat in water and then combine to thicken the water and increase viscosity. Throughout each case, the polymers form a matrix and improve water viscosity and allows first, physical stabilization and prevention of migration of suspended active pharmaceutical ingredients crystal. Second, preservation of product homogeneity during shelf life. Third, clean, no spill, no transfer of the substance from the primary package to the skin surface. And last but not least, fast spreading and appropriate aesthetics. Rheology. Most factors relating to quality depends on the product's rheology. Hence, translating these quality factors related to perception into rheological requirements becomes essential. First, it should spread easily when rubbed on the skin. Second, it should not readily flow by gravity. And last but not least, sensorial perception. For spreads easily when rubbed on the skin, the most important factors deciding the product's ability to easily spread are its rheological nature, its resting viscosity, and its viscosity at application shear rate. In order to be easily spreadable, hand sanitizer should have low viscosity at high shear levels when applied stress, also known as pseudoplastic rheological properties, shear thinning. Next, should not readily flow by gravity. The products that are not supposed to flow easily by gravity or seem runny but are easily poured out of a container should have a yield point between 10 to 15 Pascal. And last but not least, sensorial perception. It is the most important factors in obtaining all dosage form of hand sanitizer. Should feel smooth, not oily when applied, and appears clear. The droplet size should range from 1 to 20 mm. The effectiveness of hand sanitization depends solely on the use of appropriate hand disinfectants formulated in different types and dosage forms such as solution, gel, colloid, emulsion, or suspension. Based on my research, my suggestion is that the most effective hand sanitizer products are alcohol-based hand sanitizer formulations that contain 62% until 95% alcohol because they are capable of denaturing microbial proteins and inactivating viruses. Most suitable and stable dosage form of hand sanitizers is in gel formulation. Gels and foams are more widely accepted compared to liquids, particularly in terms of handling, hard cleaning feeling, and a shorter drying time. Positive features of the gels include low residue, clean smell, fast drying, cold feeling during application, and ease of dispensing. Hand sanitizers usually divided into two groups, which are alcohol-based and alcohol-free. Alcohol-based may contain one or more types of alcohol to be applied on the hands, with or without other excipients and humectants, to destroy microbes and temporarily suppress their growth. Alcohol-based can reduce microbes effectively and rapidly that cover a large germicidal spectrum without the need for water or towel drying. On the other hand, the alcohol-free hand sanitizers make use of antiseptic chemicals to exert the antimicrobial effects. These chemicals have different mode of action and function depend on their functional chemical groups. Since they are non-flammable and mostly used at low concentration, they are relatively safer to use among children as compared to alcohol-based hand sanitizers. Mechanism of action. Alcoholic sanitizers work by dissolving microbial lipid membranes, then become inactivated. Thus, when the soap and water are not readily available, the sanitizers serve as an alternative. To exert the microbial effects, it needs the suggested minimum alcohol content of 62%. Although hand sanitizers may be less qualified than soap in healthcare settings, they are the preferred form of hand hygiene. Using alcohol-based sanitizers might improve healthcare workers' compliance with hand hygiene practices since they are easily accessible and take less time to use. Disadvantages of liquid, suspension, emulsion, and colloids. In liquid dosage form, liquid difficult to apply with low coverage due to fast evaporation in lower doses. High doses cause more skin irritation and producing more residue. In suspension dosage form, the physical stability, sedimentation, and compaction can cause problems. Strong sedimentation rarely gives back product shape. It may lead to cakes, which is hard to dispense. Pharmaceutical emulsion is thermodynamically unstable and difficult to manufacture. Improper formulation can result in creaming and cracking. Therefore, it must be formulated to stabilize the emulsion from separation of the two phases. Collodion is a solution for either an acetate nitrocellulose, sometimes with alcohol supplement. A dry celluloid-like film is left on the skin as the volatile solvents evaporate. Hence, it is not effective to kill the germs because of fast drying rate. Benefits of gel dosage form in rheological properties. The test resulted in the dispersive power testing of the hand sanitizer gel dosage, indicating that the dispersive power between 5 to 7 cm show a semi-solid consistency that is very convenient to use. In addition, gel dosage sprays easily when rubbed on the skin and not readily flow by gravity after being applied. Proper hand hygiene is one of the key techniques for infection prevention, as it can undeniably reduce the risk of microorganisms being spread directly or indirectly. Because of their rapid action and efficiency in killing microorganisms, the use of alcohol-based in gel formulation is becoming more common, particularly when hand washing with soap and water is not practical or not convenient. However, there are some situations where hand washing is preferred, as alcohol-based is less effective when the hands are visibly dirty or stained and unable to cover certain types of pathogens. To ensure that all microorganisms are effectively killed, it is vital to select alcohol-based with appropriate amount of alcohol and to practice the correct hand hygiene techniques when cleaning hands. Topical drug formulators have a wide variety of dosage form options such as ointments, creams, lotions, gels, wipes, swabs, spray, and foams. When deciding on the product design and selecting a suitable dosage form, topical drug formulators consider many challenges concerning the delivery method. Formulators are searching for options that are not only consumer-friendly but also solve the challenges of formulation. Formulators consider numerous factors including indication site of application, patient compliance, ease of stability, and compatibility and stability with active pharmaceutical ingredient. Main component is the need to apply drug product to the surface of the skin in a safe, efficient, and targeted manner. Formulators must ensure that the active ingredients are delivered for effectiveness to the appropriate compartment and take effect in a suitable time frame. For several purposes, topical product developers are constantly searching for novel or different dosage formulations, including improved or safer routes for the drug delivery, protection of sensitive reactive active pharmaceutical ingredients and their stabilization, increased solutions of insoluble active pharmaceutical ingredients, improving the sensory properties, applicability, and acceptance of patients, extending the exclusivity of the active pharmaceutical ingredient or the patent life and cost saving.
From pharmacist's perspective, the most suitable hand sanitizer is formulated in gel dosage from between 62% to 95% alcohol. Major ingredients in them are glycerol, ethanol, or viscosity enhancer. From rheology perspective, gel properties should behave as pseudoplastic behavior with the isotropic property. Thus, it spreads easily when rubbed on the skin and not readily flow by gravity after being applied, giving ease of handling with highest efficacy. Liquid formulation is least favored due to fast evaporation at low doses with sticky problems. Besides, excessive dripping creates a potential slip hazard on the floor. Suspension and emulsion formulation not suitable because it is difficult to be manufactured by pharmaceutical industry due to their physical instability such as creaming and caking.